In a general to specific beam search, here the decision tree is written in the form of an if-then rules. So the database that is being considered here, it is each and every condition, it could be written in the form of an if-then rules like this. So if I have considered the humidity as the best rule here based on the entropy and the gain. So the same way you can consider the next case some other, that is a temperature also you can consider and continue the process, and finally you will arrive at the plate and S condition. So wherever you have an S conditions, so that is considered to be as an positive examples, and these conditions are written as a single rule, that in the form of an if then rule. So this is your general to specific beam search. So where you are going from a general hypothesis to the most specific rule. So that is your general to specific hypothesis. Now let's see the general to specific hypothesis algorithm. So let's understand how the algorithm is written first. So in a general to specific greedy beam search algorithm, so beam search algorithm, so we are going to consider the performance metric. Based on the performance metric, the searching of a best rule is performed. So beam search, it is known as an heuristic search algorithm. Here it finds the best rule with reduced memory. So the first step here is, first the best hypothesis, it is initialized to the most general hypothesis. So the general hypothesis, in the sense it can take any of the value. The second step here is initialize the candidate hypothesis. Hypothesis and hypothesis. See, understand the difference here. This hypothesis indicates that it is a plural form, and this hypothesis indicates that it is a singular form. Means this is a single value and this is a plural where it can have the set. So candidate hypothesis, it is nothing but a user defined set of hypothesis. It is initialized to a best hypothesis. Now if the candidate hypothesis, it is not empty, means there is a certain set of candidate predictions, then in such a case the first step is generate the next more specific candidate hypothesis. So most specific candidate hypothesis is chosen here. Update the best hypothesis H, where H is the number of conflicts. Next, update the candidate hypothesis. Then finally return a rule of the form. If the best hypothesis is correct, then predict, else again perform the iteration steps. So this is the explanation for an algorithm, or you can say that it is a step-by-step process of an algorithm. So the first step here, it is performing an general to specific greedy beam search. The first step here is to consider the best hypothesis. The best hypothesis, whatever is present as per the decision tree, it is being assigned to the general hypothesis, where the general hypothesis can take any of the value. Next, the candidate hypothesis is considered. The candidate hypothesis, it is nothing but the set of a user defined hypothesis or a prediction. It is assigned to or initialized to the best hypothesis. When the candidate hypothesis is not empty, next generate the most specific candidate hypothesis. So you are going to consider the candidate hypothesis. In that candidate hypothesis, you are going to choose the best hypothesis H. Now you are going to update the candidate hypothesis and you are going to return the rule. The rule here, it is based on an if-then rule. If the best hypothesis is correct, then predict it, or else repeat the steps. So now let's see the algorithm. So this is the algorithm of a general to specific hypothesis. Now let's understand. Learn one rule. Learn one rule, it is a subroutine that is written. So where it is going to return a single rule. The single rule we are using, it is in the form of an if-then rule. So learn one rule. Here we are going to pass the parameters, that is an target attributes example k. So k here, it is a number of best candidates in a particular training example. I told since it is a sequential greedy search, we are going to perform the step-by-step training examples we are going to consider. So return a single rule that covers some of the examples, that is a training example. Conduct a general to specific greedy beam search for the best rule guided by the performance metric. So here we are going to find out the single rule based on the performance metric. Next, initialize the best hypothesis to the general hypothesis, that is the first step. Next, the second step is initialize the candidate hypothesis to the best hypothesis. While the candidate hypothesis it is not empty, perform or do generate the next more specific candidate hypothesis. So all the constraints, the set of all constraints, that is of the form A equal to V, where A it is nothing but the member of the attribute and V is nothing but the value of that attribute. Here, as we all know, that is sky, temperature, wind. All these are the attributes, and the attribute values are sunny, strong, weak, normal. All these are the attribute values. So here we are going to compare the attribute and an attribute value. If it is matching as per the decision tree, then that condition is chosen. Now, new candidate hypothesis for each H in candidate hypothesis. Now, what is meant by candidate hypothesis is, so suppose I have considered the wind as one attribute, so that all the attribute values that is being present for an wind, that is an attribute, it is considered to be as one candidate hypothesis. Like this, we have many such candidate hypotheses for temperature, for sky, for wind. So all these are the candidate hypothesis. Now the new candidate hypothesis, it has been considered for each H in a candidate hypothesis. For each C is nothing but a constraint in a candidate hypothesis. Create a specialization of H by adding the constraint C. Now as and when we are choosing the new hypothesis, new candidate hypothesis, we are going to consider the hypothesis along with its constraint. In the sense, here if this example is considered, so this is considered to be as an A and this is considered to be as a V. So this is an attribute and this is the attribute value. If this condition is satisfied, then we are going to get an H. So now H is updated every time. So now along with the constraint, in the sense, so in this condition we have chosen H along with the second constraint, that is this condition, that is, so this is an H, humidity equal to normal. So here we have chosen this is one of the hypothesis out of the complete candidate hypothesis. So this H along with the constraint that is added, that is wind equal to weak. So that is a constraint. So now remove from, create a specialization of H by adding the constraint C. Remove from new candidate hypothesis any hypothesis that duplicates, inconsistent, or not maximally specific. So suppose here temperature we have not considered, since humidity and temperature it is going to give the same meaning, so that's why it is forming as a duplication and we are going to remove the temperature attribute. Next, second step here is update the best hypothesis. So when we have got the best hypothesis in a candidate hypothesis, so we are going to update it as a best hypothesis based on the performance metric. If performance of H, examples, target attribute is greater than performance of best hypothesis, example, target. So here H I have told it is the new hypothesis which is more when compared to the best hypothesis. So this H is considered to be as a best hypothesis. That is, so here humidity is considered to be as the best hypothesis. That's why from the humidity we have shown many possibilities of humidity, many constraints of humidity, that is wind equal to weak, wind equal to strong, outlook equal to sunny, outlook equal to rain. So it is the constraints on H. So many such constraints on H it is shown, and this is considered to be as an H. So all these are candidate hypotheses. So now we are going to update the best hypothesis as H. So best hypothesis chosen here as H. Next is, third step is update the candidate hypothesis. Candidate hypothesis, that is the K best number of new candidate hypothesis according to the performance metric, it is being updated. Now it is going to return a rule of the form, if best hypothesis, then perform the prediction. Where prediction is the most frequent value of a target attribute, we know that the prediction here, it is nothing but that is a final target output, that is playing a tennis, yes or not. So that is a final target output of ours for the considered database among those example. Now what is meant by performance is, the algorithm is only up to here, and this is an explanation about the performance. Performance, it is a subroutine, so where it is going to calculate the quality of the attribute. Here we have considered performance and we have considered the parameters H, comma example, comma target attribute. H example, that is a hypothesis example, the subset of examples that matches the H, return the entropy H examples. So here the hypothesis is going to be returned and it is considered to be as the best candidate hypothesis based on the calculation of the entropy. So here we have chosen humidity out of wind, we have chosen or temperature or many such attributes. We have chosen humidity as the best hypothesis, that is H. Why? Because based on the calculation of an entropy. Now how to calculate the entropy, and again it has already been explained in the regular class. So this is considered to be as an best hypothesis. Now all these are considered to be as a constraint, and we have to update it this H as the best hypothesis and generate a single if then rule which consisted of all these conditions. Now if the best hypothesis is correct, then perform the prediction. So this is an algorithm of this is the complete algorithm of an general to specific beam search for an play tennis database that has been considered. So this is an explanation of this algorithm. So here it is performed in these steps. So how the algorithm it is written, the same way we have to write it.